Good morning, good afternoon, good evening. In our today's video, we're going to consider the quantifiers, nested quantifiers, in the negation logic. So let us have an overview of what we're going to take a look at. Firstly, we're going to understand the meaning of quantifiers in logic. Then we're going to distinguish universal quantifiers, being denoted by this one, inverted A, and the existential quantifiers, being denoted by the E facing the left side. The other one here, we're going to consider the nested quantifiers as well as their order of operation, or how order affects the meaning of these nested quantifiers. And from there, we're going to take a look at negation of the quantified statements, and finally we're going to take out implications and their negations. So I'll be doing these videos in the series of them so that we can manage uh, the mobile data easily. So let us get to the first one, the first part of the video. So the first part of the video is going to take a look at the meaning of the quantifiers as well as the nested quantifiers and how we can negate them. So the quantifiers are in two types or in two groups, whereby the first one is what we call the universal quantifier, and the second one is the existential quantifier. Now, these are said to be one of those important things in logic that determines how valid is our statement. For the universal quantifier, as I said earlier on, it is denoted by the symbol inverted E, like this one, A, whereby we are saying for every x in the set A, then P of x is true. Now, this statement is being read as for all x in A, then the statement P of x is true. Or in other words, for every element x in the set A, then the proposition P of x is true, as we have seen in the chapter proposition or in the series of the videos that I've already uploaded on. So this one is said to be the proposition P of x. So this says for every element x in A, then the proposition P of x is true. Like any element that you can pick from the set A, it will make this proposition to be true. Now let us have an example as in how we can apply that one. So my apologies for the symbol here, so I'll collect this one. We're saying for every element x in the set of reals, or for every real number x, 2x is greater than or equal to x. For every real number x, then 2x is greater than or equal to x, like that one. So let us pick a number by number. If we choose 0 and plug 0 here, this will reduce this to 0. And this one will be 0 as well because our x is 0. So that one being 0, it means this one, the proposition itself is going to be true. Like 0 is greater than or equal to 0. That is true. Let us pick another number, half. If we plug in half here, what are we going to have? So 2 divide 2 times 1 over 2, it will give us 1, but here we're having half. And this is true that 1 is greater than or equal to half, or like 1 is greater than half, like that one. So this one is true as well. So for any number that you can pick in this set of reals, it will make this one to be true. So that's exactly what is in universal quantifiers. And I'll have the series of the examples as we go on. On existential quantifier, we're going to say this one denotes the existential quantifier. This one is from the set theory. This one is just the set, and this one is just the proposition, as I said here. Now here it says now here the issue is there exists an element x in the set A such that P of x is true. What are we trying to mean here is if we pick any element x in the set A, and plug it in here, this one is going to be true always, like that one. So let us have the first example. There exists an element x in the set of reals such that 2x is going to be 5x squared plus 2x. Now in this one, as I said, we just look for at least one element in this set that will make this one to be true. Not every element, but just at least one. If we have one or two or three or how many of them are going to be, but as long as we are having one, this one is going to be true and is considered false otherwise. So let us look at this one. What if we choose our x to be equal to 0? If we plug in 0 here, we're going to have 0. If you plug in 0 here, we're going to have 0 plus 0, which will give us 0. And this is indeed true that 0 is going to be equal to 0, and this one is true. So for the existential quantifier, we just look for at least one element. And if we plug in that one element into that set, then this one is going to be true. So in our next video, we're going to take a look at the negation of the we're going to have a look at nested quantifiers and how order affects them. As I said earlier on, we are going to have just the series of the videos. Thanks for watching.